Leigh Industries' policy is one of continuous product improvement. Because of this, some features of the new and improved model D4R jig you have received will not match the appearance of the D4 jig in this program. However, the finger assembly with its scales and jig settings and virtually all operating procedures are absolutely identical for both jig models. Where they are not, the change is clearly captioned. Leigh Jigs, joining tradition with today. Welcome to a way to add strength, beauty, and versatility to all your woodworking projects. The Leigh Dovetail Jig. Now you can quickly create attractive dovetails for all types of furniture. The Leigh Jig's patented finger assembly makes this easy by producing corresponding pins and tails from the same setup. And the Leigh Jig allows for an infinite variety of joint designs. This video is an overview to introduce you to the Leigh Dovetail Jig and its capabilities. It is designed to take you through key components of the jig and to outline procedures for woodworking. Part 1 of this video covers the operation of the Leigh Dovetail Jig. Part 2 looks at basic jig functions. Part 3 shows you how to use the Leigh Jig to create through dovetails. Part 4 illustrates half-blind dovetails. Part 5 covers asymmetrical dovetails. Part 6, sliding dovetails. Part 7 presents some tips and hints for effective use of your Leigh Jig. And Part 8 covers guide bush and cutter selection. Please read the user guide for instructions on how to set up your Leigh Jig and for complete illustrated instructions on all aspects of dovetail creation. Throughout this video, you will see a number of different models of routers in use. You will require only one. Depending on voltage, we recommend a minimum of 10 amps or 900 watts with a half-inch collet capacity. Throughout this video, we will use a set of symbols to indicate wood placement. These same symbols are used in the user guide. This symbol means this side of the workpiece will end up facing out on the finished project. This symbol indicates that this side will be facing in on the finished piece. This symbol means that this side of the workpiece can face either in or out. Before we move into the particulars of the Leigh Jig, let's take a moment to look at safety. As with all woodworking activities, your safety is of primary importance. The router, with its high-speed rotation and sharp cutters, presents a number of hazards. So before using a router with the Leigh Jig, carefully read the router owner's manual. When it is not in use, or when you are fitting cutters or guide bushes, always unplug your router. Always wear hearing protection when using a router. Always wear approved safety glasses. And if you're doing a lot of routing, it's a good idea to protect yourself from harmful dust by wearing a face mask. Before connecting the router to the power source, make sure the cutter and collet revolve freely in all of the areas you plan to route, and that the cutter does not touch the guide bush or jig. Don't tilt the router in the jig. Keep it flat on the jig finger assembly. If you insist on removing the router from the jig while it is still revolving, always pull it straight off the jig horizontally. And do not raise or lower the router until it is completely clear of the jig. Never route at face level. If you have never used your router before, Make plenty of simple open-face practice cuts without a guide bush before you try to use the router on the Leigh jig. When using the jig, you will always use a guide bush. Operation. The Leigh Dovetail jig works by allowing an almost infinite number of selections for joint size, spacing, tightness of fit, and adjustment. The two clamp bars clamp workpieces horizontally or vertically. The side stops align the boards in the same position each time. The guide finger assembly can be moved in or out, and on each end there are calibrated scales to adjust to different thicknesses of vertical boards. The finger assembly can also be raised or lowered using the support brackets to adjust to different thicknesses of horizontal boards. The finger assembly attaches to the support brackets in 4 different modes to match the type of joint you are cutting. Always read scales from directly overhead to avoid parallax problems. The active scale is always on the right of each assembly. The inactive scale is always on the left of each scale assembly and is upside down. Each scale has its own mode icon, which looks like the joint part which is made in the mode. For further clarity, the scales are color-coded. Through dovetails are on a silver background. The green background is for half-blind dovetails. Basic jig functions: through dovetails, half-blind dovetails, and sliding dovetails. To demonstrate the basic operation of the Leigh jig, let's look at positioning the finger assembly. We'll start with the finger assembly in the through dovetail tails mode. Rotate the finger assembly towards you 180 degrees. Now the finger assembly is in the through dovetail pins mode. Flip the finger assembly end over end 180 degrees. Now the finger assembly is in the half-blind dovetail pin mode. Again, rotate the finger assembly towards you 180 degrees. Now the finger assembly is in the half-blind dovetail tails mode. Using the cross-cut fence in the half-blind tail mode allows you to cut sliding dovetails. Through dovetails. With through dovetails, the pins fit in the pin sockets. The joints almost always end at each side with half pins. To create a simple square test box, you will need 5 identical boards, 3/4 of an inch by 5.5 inches by 8 inches long or similar size. 4 boards will be used to create the box. The 5th will be used for testing for fit. To start, mark the inside faces of the tail boards and the outside faces of the pin boards. Because we're using 3/4 inch thick boards, we use a router with a 7/16 inch outside diameter guide bush and a number 80 1/2 by 8 degree dovetail cutter and a number 140 5/16 inch straight cutter. Fit the 7/16 inch guide bush securely to the router. Fit the number 80 dovetail cutter to the router. Make up a spacer board as specified in the user guide and clamp it in the rear clamp. Place the finger assembly on the support brackets in the through dovetails pins mode. For initial adjustment, set the scale to the 1/2 inch setting. Always support the finger assembly with the spacer board when using the front clamp. Now clamp one of the pin boards in the left side of the front clamp against the side stop, with the top edge flush under and touching the guide fingers, and the outside face away from the jig body. Loosen the support bracket knobs and raise the finger assembly about 1/16 of an inch above the boards. This allows easy and accurate guide finger adjustment. Although you will cut the tails first, adjust the guide finger layout in the Through Dovetails Pins mode, because it is easier to visualize the finished joint pattern. The adjustment screws are on top in this mode. The following joint design is only a suggestion for this trial. It has a typical and traditional symmetrical layout of pins with half pins at each edge. The outer guide finger next to the scale is there to support the router. Ignore it and loosen the next 8 guide fingers and slide them over the top of the workpiece. Lock the left half-pin guide finger about 1/8 of an inch in from the left edge of the board, and lock the right half-pin guide finger about 1/8 of an inch in from the right edge of the board. Judge this distance by eye. It doesn't need to be exact. The Leigh Dovetail guide finger assembly will ensure that the sockets and pins align automatically. Space and lock the 3 remaining pairs. Again, judge by eye. If it looks right on the jig, the finished joint will look right. Tighten all loose guide fingers to ensure a flush, level guide surface. Always push down on the center of each guide finger when tightening the screws. Remove the pin board. Rotate the finger assembly to the Through Dovetail Tails mode. Set the scale to the 1-inch position. All Through Dovetail tails are routed at this setting. Lower the finger assembly onto the spacer board. Now clamp the tail board vertically, touching the side stop, with the inside face of the board away from the jig. Place the end of a pin board horizontally and flush under the guide fingers. Now mark a thin pencil line partly across the tail board. Place the router on the finger assembly and adjust the router until the dovetail cutter tip is level with the center of the pencil line. Now route out the half pin and pin sockets. Release the clamp and reverse the tail board in the jig, keeping the inside face away from the jig body. Route the other end of this tail board and both ends of the second tail board. Now rotate the finger assembly to the TD pins mode. Don't change the guide finger layout. The tightness of the finished joint is determined in the Through Dovetails pins mode. The further out towards the operator the finger assembly is set, the larger the pins will be. The further in towards the jig the assembly is set, the smaller the pins will be. Set the Through Dovetail pin scale 2 divisions above the half-inch reading. This should result in oversized pins for the first test. The dimensions in this triangular panel indicate the width of the pin to be routed. These dimensions match the size of the dovetail cutter used to route the tails. In this case, 1/2 an inch. So, set the Through Dovetail pin scale to the half-inch reading for the first test. Clamp a test pin board against the left-hand side stop, outside face away from the jig, with the top end flush under the guides. Through Dovetail pins are the only boards on which the outside face faces out on the jig. Place the side edge of one of the cut tail boards flush under the guide fingers and mark a pencil line partway across the pin board. Unplug your router and remove the dovetail cutter. Replace it with a number 140 5/16 straight cutter. Place the router on the finger assembly and adjust the router until the cutter tip is level with the center of the pencil line. Route out the waste between the pins. Remove the test pin board and test it for fit in one of the previously cut tail boards. The joint will probably be too tight. If it is too tight, move the finger assembly away from you by 1 division on the scale. Replace the test piece and align it against the same side stop. Then route the sides of the pins again. Retest the fit. You can repeat this procedure, taking a bit more off each time until the fit is perfect. If the joint is loose, pull the joint apart. The gap at the bottom of the pins is the distance you should move the finger assembly forward on the jig. Then route a fresh set of pins to test. When the correct fit is achieved, mark the TD pin setting for future reference on the scale prints in your user guide. Now you can route all 4 ends of the pin boards, keeping the outside face outwards each time. Assemble the box with the inside of the tails inward and the outside of the pins outward. Any pin end will fit any tail end. The Leigh finger assembly ensures perfect alignment every time. Creating half-blind dovetails. With half-blind dovetails, the pins fit in the pin sockets. Joints are almost always laid out so that each side edge ends with a half pin. Both pins and tails for half-blind dovetails are cut with the same dovetail cutter. Clamp the spacer board in the rear clamp. Mount the finger assembly on the support brackets in the half-blind tails mode. Ensure that it is flat on the spacer board. The half-blind scale set is always set at the tail board thickness. In this case, 3/4 of an inch. We are going to cut some test joints for fit. Clamp one of the test tail boards in the left front clamp, against the side stop, with the top edge flush under the guide fingers, and the inside face of the tailboard away from the jig. Now, unlock and raise the finger assembly slightly so the finger assembly is about 1/16 of an inch above the boards. This will allow easy movement of the guide fingers. The extreme outer guide finger next to the scale just supports the router. Ignore it and loosen off the adjacent guides so you can create the tail layout. Remember to tighten any loose guide fingers. If the gaps between the guide finger tails are wider than 1/8 of an inch, mark off and cut some pieces of the included extrusion to fit into the slots in the end of the guide finger tails. The friction fit ensures that the bridge pieces will not fall out. Be sure to make them slightly shorter than the distance between the guide finger shoulders, so the guide fingers will not be forced apart when you put in the bridge pieces. Now lower the finger assembly back onto the spacer board and workpiece. The finger assembly must touch the workpiece or the depth of cut will vary and the joint won't fit properly. The scale should be set on the tailboard thickness. In this case, 3/4 of an inch. Attach the 7/16 inch guide bush to the router securely. 7/16 guide bushes are used on all half-blind dovetailing. Mount either the number 120 or number 101 cutter to the router. To start, set the cut depth to the amount specified in the half-blind cutter chart in your user guide. You cannot change this except for minor adjustments to fit. Raising the cutter makes the pins narrower, while the pin socket stays the same width. producing a loose fit. Lowering the cutter makes the pins larger, while the pin socket stays the same width, producing a tighter fit. For the first light cut, move the router from right to left. Because the router is driven in this direction by the rotation of the cutter, make sure you control it firmly. Use only the tip of the cutter for the first pass. This back or climb routing leaves a very clean shoulder in side grain. Now route in and out from left to right, following the guides and bridge pieces. You are routing the pin sockets, leaving the tails. Remove the test tail board. Then clamp a scrap board in the front of the jig so the top edge projects above the top face of the jig about 1/8 of an inch. Now remove the spacer board from the rear clamp. Place a test pin board in the left rear clamp with the inside face of the drawer front away from the jig body, against the side stop, fitting its front edge flush against the vertical scrap piece. Rotate the finger assembly to the HB pin scale. You will use the same setting as for the tails, in this case 3/4 of an inch. Both the half-blind pins and half-blind tail scales are always set to the tail board thickness. Make sure the finger assembly is flush and level on top of the pin board. The guide fingers must be touching the pin boards, or the depth of cut will vary and cause poor joint fit. If you have difficulty leveling the finger assembly on a narrow workpiece, place a board of the same thickness as the pin board under the other end of the finger assembly, but not in the rear clamp. When the guide finger assembly is set, route out the waste between the pins. Route each space from left to right. If the cutter enters on the right side of the opening, there'll be a very strong pull to the left. So, route each opening in at least 3 or 4 passes left to right. Do not back or climb route on end grain. When finished, remove the pin board and test the joint for fit. If the joint is loose, pull the joint apart. The gap at the bottom of the pins is about the distance you should lower the cutter. Lower the cutter slightly and test again with 2 fresh board ends. If the joint is too tight, raise the cutter slightly and test again. You cannot route the same board end twice with a dovetail cutter, so use 2 fresh board ends each time. Keep the test tail board that fits well and mark it with the number of the cutter you use to route it. For quick setup next time, clamp this test tail board in the jig as a depth of cut gauge to show you how far to lower the cutter. Or if you have a caliper, measure the cutter projection from the cutter tip to the guide bush flange. Record this measurement for rapid router setup next time. When the fit is the proper tightness, check the flushness. The tails should be underflushed to the pins by no more than 1/64 of an inch to allow for cleanup. The concentricity of the cutter to the guide bush on different routers will affect this tolerance. If the tails stand out from the pins, set the half-blind pin scale deeper by the amount required. If the tails fit in too far past the pin ends, set the half-blind pin scale further out towards the operator by the amount required. Rabbeted half-blind dovetails. A good example of a rabbeted half-blind dovetail is in a drawer front. You mount and route rabbeted drawer fronts and sides in exactly the same way as flush fronts, except make up a scrap block the same thickness as the rabbet depth to space the stop block away from the jig face. This brings the pin ends exactly in line with the front jig face, ensuring that the scale readings are accurate. Make sure you select a dovetail cutter that has a working depth of cut less than the rabbet height. Otherwise, you will route into the rabbet. It is difficult to clean up the drawer sides and front after assembling a rabbeted drawer. So, make sure the fit is flush before you complete the drawers. Asymmetric dovetails. A symmetrical joint is one that looks symmetrical about its center line, even though it may not be precisely symmetrical. An asymmetrical joint is one which has been deliberately laid out with uneven pins and tails. Project designs for things like chests or boxes may require asymmetrical joints. In this case, one pin is made wider for a saw-cut allowance. So the half pins on both lid and chest will all look the same width after the lid is cut off. You can see that if both ends of the board are cut under the same asymmetrical guide fingers at one end of the jig, the wide pins at opposite ends will not line up. Remember, the same outside face of through dovetail pin boards have to face away from the jig for each cut. Therefore, deliberately asymmetrical joints must be routed on both ends of the jig using two separate, almost mirror image layouts. For a typical blanket chest, you would route corners A and C on one end of the jig and corners B and D on the other end. Here is an easy way to cut these near mirror image joints. Lay out and route the A and C corner joints in the usual way. Leave the guide fingers set in the through dovetail pins mode. Take a square cut scrap board marked to indicate which face is out on the jig and clamp it in the front clamp. And butt it against the same side stop you use for the A and C joints. Pull the finger assembly forward until the bracket line is on the highest scale reading. Mark pencil lines across the top edge of the scrap board and along the bottom of each side of each guide finger or pair of guide fingers. Turn the board like turning a page of a book to the other end of the jig, up against the side stop. The inside face is now away from the jig. Now adjust the guide fingers at the end to match the pencil lines. Now route the B and D corner tails and pins using this guide finger pattern. When you assemble the case, the A and or C ends will fit each other, and the B and or D ends will also fit each other. Keep the board's inside face inwards on the case, and the parts are sure to match. To transfer a mirror image asymmetrical half-blind joint, first set the scale on 1 inch in the half-blind tails mode. Mark pencil lines next to the tail guides and turn the marked board like turning a page of a book to the other end of the jig. Position the guide fingers over the pencil marks. With the finger assembly in the half-blind tails mode, the cross-cut fence fits into the recesses in the ends of the tail guides to allow routing of sliding dovetails. Using the cross-cut fence as a guide surface for the guide bush, you can make lateral router cuts across the faces of horizontal boards to route sliding dovetail slots, and across the top end of vertical boards to cut the tails. You can use virtually any guide bush dovetail cutter combination for sliding dovetails. But make sure the cutter can rotate without touching either the guide bush or the jig. Mark a narrow test slot board at several closely spaced places and square the marks across the face. These boards are used only for setup. To start, mount a test slot board in the rear clamp. Then mount a 3/4 inch thick square-ended board vertically in the front clamp, with the top edge butting the underside of the test board. The 3/4 inch thickness is important. Now position and clamp the test board so that one of the edge marks is in line with the outside edge of the vertical board. With the finger assembly on the support brackets in the half-blind tails mode, set the scale to 9/16 inches. With the 3/4 inch thick board in the front clamp, the crosscut fence should be set in the correct position. Make sure the finger assembly is level and sitting flush on top of the board. Adjust the cutter so the cut depth is about 1/3 the thickness of the wood. This is the best depth for sliding dovetails. Route from left to right, maintaining light inward pressure of the guide bush on the fence. Route in only about 1 inch, then back out again. Check to see if the short slot you have cut is centered on the pencil line. If not, adjust the finger assembly in or out and retest on the other lines as necessary until the slot is centered. Record the setting for future reference. Put the workpiece in the horizontal position in the rear clamp. Slot side, that is, inside face, up. The guide fingers must be flush on the board. Now route the sliding dovetail slots in the main slot boards. Now you can cut all the way through. Or stop to create a stop sliding dovetail slot. Replace the spacer board in the rear clamp. And with the finger assembly on the spacer board, mount the test tail board vertically in the front clamp, flush with the guide fingers. Either side can face out. The half-blind tail scale is not designed specifically for this mode, but it does allow you to make precise adjustments for tail size and tightness of fit on sliding dovetails. Adjust and set the finger assembly so it is clear that the routed tail will be too large for the slot. Then route one side of the test tail board. The depth of cut is, of course, the same as for the slots. Make one light pass from right to left. Make sure you control it firmly, because it is driven in this direction by the cutter. Only the tip of the cutter should be cutting on the first cut. This back or climb routing leaves a very clean shoulder on side grain. And finish left to right, with the guide bush touching the bar. Turn the test tail board around in the jig and route the other side as before. Test the joint for fit. It should be too big. If it is, move the finger assembly in toward the jig by half the amount the tail is too big. Route the same test board again, and keep adjusting and testing until you have a good fit. If it is too small, adjust the finger assembly outward by at least half the difference, and route another test tail on the other end of the test board. Tolerances in board thickness, guide bush diameter, cutter depth, angle, diameter, and concentricity make it impractical to record or chart each setting for sliding tail size. Using trial and error each time, it doesn't take long to learn how to produce a good fit. When the fit is satisfactory, route one end of a project tailboard and test again. If the fit is good, route all the other ends. Hints and tips. Every time you use the lead jig, you'll be using the cam action speed clamps. Get used to the feel of the clamp. A smooth, firm thumb pressure is about right. Don't force it. And don't use the lever as a torque arm. Adjust the clamp tension only with the clamp disengaged. When engaged, the front clamp levers should point down, and the rear clamp levers should point away from the operator. If the lever is badly positioned at the correct clamping pressure, release the clamp and remove the board. Turn the step washer 1/4 turn. The step height in the step washer changes the clamp position by 1/4 the clamp bolt thread pitch. Now adjust the clamp to the right position at the correct pressure. On narrow boards, the clamp at the free end should be taken down a couple of extra turns. The bar should bow down slightly at the free end for secure clamping. For all but the wider boards, you need only operate the clamp on the board end. Unfortunately, as with any cutting tool in wood, there is no absolute solution to tear out. But there are some things you can do to help minimize the problem. To prevent tear out at the back bottom part of a straight cut, scribe a line with your marking gauge across the back of the pin board at exactly the depth of cut. With the straight cutter on through dovetail pins, carefully climb route from right to left. Make sure you control the router firmly when climb routing. Route through on the right side. Then climb route from left to right, across the rear of the cut. Route back through towards you on the left side. Route away the rest of the waste. With the dovetail cutter, most tear out occurs at the top left exit of the cutter. To help prevent this, back up the cut with a horizontal board with its end grain pushed against the back of the workpiece and held in the rear clamp. This same scrap piece can remain in place for successive cuts. For particularly vulnerable pieces or that last piece of exotic wood, the best solution is to clamp scrap pieces to front and back of the workpiece. Make sure the clamps are below the cutter depth. On face cuts, whether using a straight cutter or a dovetail cutter, climb routing or back routing will leave a clean edge. But great caution must be exercised in controlling the router's movement from right to left, as the cutter rotation pulls the router in that direction anyway. Here are some tips on how to more safely and effectively steer your router. It helps to mark the router base top edge at the 12 o'clock position with a felt marker pen, so you will always be able to check the relative position. Without wood or cutters, try some dry runs in each jig mode. This will soon get you used to correctly positioning the guide bush against the correct guide surface without looking under the router. Some router bases have sharp edges on the outside and inside corners. A slight chamfer of the edges with a fine file or sandpaper will remove sharp edges and ease router movement on the jig. An occasional light application of soft wax on the router base makes for smooth, easy router movement on the jig. Guide bush and cutter selection. Only two sizes of guide bush are used with the Leigh jig: 7/16 inch outside diameter and 5/8 inch outside diameter. Use the 7/16 inch for all half-blind dovetailing and for through dovetailing with 1/4 inch or 8 mm shank cutters. Use the 5/8 inch outside diameter for large through dovetail cutter combinations with 1/2 inch shanks. Use the user guide selection chart to determine the adapter and guide bush required for your router. A 1/2 inch collet is necessary for the large through dovetail cutters. All other cutters are available in either 8 mm or 1/4 inch shanks. We recommend the stiffer 8 mm shanks for best results. Use 8mm shanks with the Leigh number 172-8 1/2" to 8mm collet reducer, or directly in 8mm collets where available. Always insert the shank as far as possible into the collet, and keep the collet as close to the cutter head as possible. See your Leigh user guide for the best way to accomplish this. The Leigh Dovetail Jig is a unique woodworking tool. It allows you to add a professional touch to all your work. This video has given you an overview. For more complete instructions, please use your user guide, which is recognized as the premier instruction guide in the industry. Enjoy your Leigh jig safely. And if you have any questions, you can call our helplines listed in the back of your user guide. Not only is the Leigh Dovetail Jig the most versatile dovetail jig in the world, it's also the basis of an incredible router joinery system. There are a number of optional joinery attachments which fit directly to the jig body to greatly expand your joinery capabilities. The M2 Multiple Mortise and Tenon attachment, the world's only routing fixture for making this difficult-to-cut joint. With the M2, you can route perfectly fitting and aligned rows of mortises and tenons, with either rounded corners or with squared corners for a more traditional look. You can make box joints from 5/8 inches and up in any variable layout. The F1 finger joint template is a unique self-contained joinery system. With it, you can route 9 sizes of box joints from tiny 1/16 of an inch up to 1/2 inch. 4 sizes of half-blind rounded finger joints are available, as well as through round to square box joints. All this versatility comes with absolutely precise and positive control of joint tightness using VGS, the Leigh Variable Guide Bush System, the only adjustable guide bush system available. An unprecedented new dimension has been added to router joinery by the 3 new Leigh Isoloc joint templates. They allow you to create 6 incredibly beautiful half-blind and through joints, with or without inlay bands. There is literally no limit to Isoloc designs, an infinite world of decorative joinery at your fingertips. And Isoloc joints are not only beautiful, they are incredibly strong, combining the best of mechanical interlocking dovetails with the multiple glue surfaces of box joints. And you get perfect tight joints with the included Leigh Variable Guide Bush System. Leigh Jigs, joining tradition with today.